Hello class, welcome to another lesson. Our learning goal for the day is I can identify proportional and non-proportional relationships from a table, graph, and equation. So we're going to start off with the table. We're going to move on then to an equation and then a graph, but today's lesson is only identifying proportional and non-proportional relationships from a table. So let's get started. Two units can have either a proportional or non-proportional relationship. Okay? And the same thing with two numbers. So a proportional relationship is a relationship in which is a relationship between two quantities in which the ratio of one quantity to the other is constant. Okay? So you guys did an activity yesterday in which you found out that the tortoise's speed was 3.5 throughout his entire walk, 3.5 inches per minute. So the tortoise maintained a constant speed. He didn't speed up. He didn't slow down. He was just going 3.5 inches every single minute. Therefore, the relationship between time and distance for that tortoise was proportional. Okay? Again, the same no matter what. So let's take a look at this. Albert types 45 words per minute. We're asked to determine if it's a proportional relationship or not. Okay? So, first we need to fill out this table. So in the first minute, he read 45 words. In the second minute, he's going to read another 45 words. So that gets us to a total of 90 words. He's going to read another 45. So we can do 3 times 45 or add 45 to 90. That gets us 135. He reads another 45, so that gets us to 180. Or 4 times 45 is 180. 5 times 45 gets us 225. Okay. So the number of words the time determines how many words he's read. So the words depend on the time. So this is called the y, okay? Also known as the dependent variable. Okay. The top part here is time. Okay. And we said that the number of words depends on time, so this is considered our x. This is called the dependent or independent, because time can change, and then that change causes the number of words read to change. Okay, so whenever we do a ratio, okay, we always do the independent is on the bottom, so that's going to be our x. Okay, so time, and our dependent is going to be on the top, y. Okay, so that's why we always have dollars per hour, right? Dollars per hour, because then that's for how much money you make, okay, per hour. And the reason for that is because the dollars that you make does not depend on how many hours, the dollars that you make depends on how many hours. The number of hours you work does not depend on how many dollars you make. Okay, you first work it, then you get the dollars. You don't get the dollars and then you work. Okay, so we're going to fill this out here. So we're going to, for each one of these, write down the time and the number of words. So 1 and 45 words. So 45. Okay, 90 words and 2 hours. And I'm just going to go across here, 3, 4, 5. These are the minutes, and these are our words. 135, 180, okay, 225. Then we divide each one of these. So 45 divided by 1 is 45. 90 divided by 2 is 45. 135 divided by 3 is 45. 180 divided by 4 is 45. 225 divided by 5 is 45. So the constant rate for this is 45 words per minute, as said in the question. Okay, so the ratios for each one of these, this is a ratio 45 to 1, 92, etc., etc., and etc. The ratios are constant. Okay, the common ratio is 45 words per minute. Okay, So because each one of these, it gets us 45. And then the relationship, therefore, is proportional because he doesn't change the speed in which he reads at all. Excuse me, proportional. Okay. Let's take a look at another one. Here we're asked to determine if it is proportional. Okay. So distance depends on time. So this, since it depends on it, is the y. This is our x. Okay. So that's why it's y. Distance is on the top. X is on the bottom. The distance depends on the time. Okay. So I'm just going to fill this in. 65 over 1. 120 over 2. 195 over 3. 220 over 4. 300 over 5. Now, then we start doing our division. 65 divided by 1 is still 65. 120, oh, excuse me, I'm going to write that down, 65 right here. 120 divided by 2 is 60. Uh-oh. These ratios aren't the same. Okay. Here, in the first hour, you got 65, right? After the second hour, he averaged 60. That means that he's not going, or excuse me, she's not going at a constant rate. So these two rates or ratios are not the same. So therefore, it is not proportional. Okay. So do you think that Allison drives at a constant speed for the entire trip? Why not? No, because her average speed changed from 1 hour to the next. From 1 hour to the next. Okay? So therefore, this is not a proportional relationship. Okay? In order for it to be a proportional relationship, these all have to be equivalent. Okay? Her speed has to be constant throughout the entire trip. The Vista Marina rents a boat for 25 hours, or $25 per hour. In addition to the rental fee, there's a $12 charge for fuel. The number of hours you rent the boat proportional to the cost, why or why not? So, the $12 fee is called a one-time fee. Okay, so you pay that up front before you even rent the boat. Okay, so for the first hour, you have to pay that charge and the $25. That gets us $37. Okay. In the next hour, you just have to pay an additional $25. You don't have to pay this $12 again. So what we're going to do is add 25 to this. That gets us 62. Okay. And then for the next hour, again, you don't have to pay this one-time fee. It's just at the beginning. So therefore, you just add 25. You get 87. Okay. So we need to figure out if these are proportional. So I'm going to fill in our table here. Again, the cost is dependent. So this is on, excuse me, it depends. So this is our y on the rental cost, rental time. Okay, let me do that again. Not x, it's y. So it depends on the rental time. Okay, the rental time can change. The cost then changes with it. So that's why this is going to be y over x. Cost depends on time. So the cost is 37, 62, 87, and we got 1, 2, 3. So we need to do division. 37 divided by 1 is still 37. 62 divided by 2 is 31. Oh, these are not equal. So therefore, this is not a proportional relationship. No, because the ratio changes. Okay, the this part right here changes in terms of the ratio, because the ratio changes from hour 1 to hour 2. Okay. And if you think about it, the reason for that is because of this one-time charge right here. Okay, this messes it up. Okay, because it's no longer constantly jumping from 25. If you had a 0 right here, it'd be 0, 0, but then you could jump it up to 37, then you jump up 25 and 25. Okay, that causes the rate to change over time. Here we're to determine the relationship between the hours worked and the amount earned for Matt and Jane. Okay. Which person, Matt or Jane, has a constant rate of pay? So here we can simply do, so the earnings depends on the time. So since this depends on it, this is the y, this is the x. So we're going to do 12 divided by 1, and 20 divided by 2, and 31 divided by 3. Here, 12 divided by 1 is 12, 20 divided by 2 is 10. Oh, these do not equal, okay? So therefore, Matt does not have a constant rate of pay. Okay? From here to here, he made $8. From here to here, he made $11, so it's not constant. Okay? Here, just to double check, we're going to do 12 over 1, 24 over 2, and 36 over 3. Okay, so this is going to be 12, this is going to be 24 divided by 2 is 12, and 36 divided by 3 is 12. So she gets paid $12 an hour, okay? As opposed to Matt, who knows how he makes his money, but apparently it's not by hour. Here we have plant A is 18 inches tall after 1 week, 36 inches tall after 2 weeks, 56 inches tall after 3 weeks. Plant B is 18 inches tall after 1 week, 36 inches tall after 2 weeks, 54 inches tall after 3 weeks, which situation represents a proportional relationship between the plants and number of weeks. We don't have a table, but we know that inches depends on the time, right? So this is going to be our x, this is going to be our y, so we're going to do y divided by x. Okay, oh, excuse me, I had that backwards. The inches depends on it, so this is our y, and this is our x. So we're going to, for plant A, 18 divided by 1, 36 divided by 2, 56 divided by 3. And for plant B, we're going to do 18 divided by 1, 36 divided by 2, and 54 divided by 3. Go ahead and figure out which one of these plants has a proportional relationship between the height and the number of weeks. What you should have discovered is that this one, plant B, is proportional, okay, because it grows at a constant rate of 18 inches per week. As opposed to this one right here, this one does not represent, is not proportional to these, okay, and so therefore this is not proportional. Here, we need to convert a temperature in degrees Celsius to degrees Fahrenheit. Multiply the temperature, the Celsius temperature by 9/5, and then add 32. Okay. Is the temperature in degrees Celsius proportional to the temperature in degrees Fahrenheit? Go ahead and fill in this table on your own. All right, so what you should have found is this should have been 32, 50, 68, and 86. Okay. Now, when we determine if this is a proportional relationship or not, the Fahrenheit depends on the Celsius. So since this is dependent, this is our y, this is our x, so we're going to do y divided by x. Okay, which gets us 32 over 0. Well, we need to do question mark. Question mark, we don't know if it's proportional or not. 50 over 10, question mark. 68 over 20, question mark. 86 over 30. Okay, we find that this is not proportional because this right here is 5, this is 3.4, okay, and this one right here we can't even do. 32 divided by 0 is not possible, so therefore this is not a proportional relationship. Okay, not proportional. So, we've been kind of doing this entire time, but just to summarize, okay, when you calculate the ratios between the quantities in the tables and the problems, you are actually calculating the unit rate, okay? Now, if the unit rate is constant, it is a proportional relationship. If the unit rate changes over time or over hours, time, or whatever the independent variable is, then it is not a proportional relationship. Okay. Go ahead and try the practice on your own.